The question that I have is, could you do an example on a cable system involving a pulley? This is the problem that I have selected in answering this question. We have a cable system here involving a smooth pulley at point B. The mass at point A is 20 kilograms, but the mass at point E is unknown. We are to find the tensions in the cables and the value of the mass m. The first step of the solution process is to identify the particles to be considered in the analysis, and here we will consider particles A, B, C, and E. The second step is to complete the free body diagram for these particles. I have done this on the main picture. Let me point out two things here. Firstly, assuming that the mass m is in kilogram, the weight associated with that would be mg, right? Since g is 9.81 meter per second squared, the weight would be 9.81 times m Newton. Secondly, since the pulley is smooth, the tension on the cable that goes around the pulley remains the same. And therefore, TBC and TAB, that's the tension in this cable, are equal to each other. So my free body diagrams already reflects that. Instead of calling this as TAB, I'm calling this as TBC. Otherwise, we'll be unnecessarily introducing an extra unknown. Not only that, unless we recognize this, we won't be able to solve the problem. Our final step is to use the equilibrium equations to answer the questions. Remember, you need to start from a free body diagram that has at most two unknowns, right? So particle C is definitely not one of those, because on particle C we have three unknowns, TBC, TCD, and TCE. But you might ask, why can't we start from particle E, since there are only two unknowns on that free body diagram, right? But that won't work either, because both of those unknowns, which are TCE and little m here, are both in the vertical direction. And you can only write down one equilibrium equation in the vertical direction, and therefore we won't be able to solve for both unknown from one equation. So your only choice is particle A. The particle A is subjected to two forces, TBC and its weight, but the weight is a known quantity. Weight is mass times G. Mass is 20 kilograms. You multiply it by 9.81. I get a value of 196.2 Newton for that. And here I am writing down an equilibrium equation in the vertical direction that gives me a value of 196.2 Newton for TBC. Now we can go to particle C, because the number of unknowns has decreased from 3 to 2. First I write down the equilibrium equation in the horizontal direction. That allows me to find a value for TCD. TCD is calculated to be 113.28 Newton. And then I write down the equilibrium equation in the vertical direction, and that allows me to find a value for TCE. TCE is calculated to be 226.6 Newton. At this point, we got all the tensions. Let's go ahead and find the mass little m. To achieve this, I consider the free body diagram for particle E. Here's my equilibrium equation in the vertical direction for the free body diagram at point E, and that allows me to calculate a value for little m. Little m is calculated to be 23.1 kilogram. To answer the questions in this problem, you didn't have to use the free body diagram for the pulley B. But if there is another question that says find the force on the support link for the pulley, then you will consider the free body diagram for the pulley. You will complete the free body diagram for the pulley, assuming that these 2 points are hinges, then the force on the link is going to be in the direction of the link. There are 2 unknowns. The direction of the link itself is an unknown, and then of course the force on the link is an unknown. You can write down 2 equilibrium equations for the free body diagram of the pulley and find these 2 unknowns.